Hello, this is question 2 from the 2022 Step 2 paper. It's a sequences question. We've got sequence un, where n is an integer, positive integer, is said to have degree d if un as a function of n is a polynomial of degree d. Okay. Part 1. Show that any sequence un that satisfies that for all n greater than or equal to 1, there is a constant difference between successive terms, and then deduce something afterwards. Right, so this is the first bit we have to deal with. So if we've got a constant difference between successive terms, so we've got an arithmetic sequence, so we're saying that un plus 1 minus un, and we've got un plus 2 in here, so let's go up to un plus 2 minus un plus 1. So that is successive pairs of terms in the sequence, and they've got a constant difference. So we'd have 2un plus 1 is equal to un plus 2 plus un, which is exactly what I want, right? So un plus 1 is a half un plus 2 plus un. Right, so that's done that bit. Now we have to deduce that any sequence un for which that is the case has degree of at most 1. Right, so we need to get some n's into this now. So this is an arithmetic sequence. We need to get n's into what we're calculating, otherwise we can't get this polynomial. So we need to, well, un in an arithmetic sequence is u1 plus n minus 1d. And is that all we need? Yeah, we've shown it is, so, well, let's put there, i.e. arithmetic sequence. So at least they know what we're thinking if they're marking this. So we've got this. I mean, that is a polynomial of degree 1, isn't it? Because we've just got that one n there, an n to the power 1. u1 and d are both constants. So let's put that in as well, where u1 and d are constants. I don't think there's really much else to say on this. So therefore, un is a polynomial in n of degree 1. So it's sort of un is equal to, well, a plus, well, actually, let's write it out as a minus d plus dn. So that's what we've got, where a and d's are constants. I've just written it out in a different way. Okay. Right, so that's done the first part of the question. Let's get a fresh sheet up for part 2. Sequence Vn satisfies that, okay, which is the same thing with a minus p at the end, right, for all n, where p is a non-zero constant, right, so we can't just get rid of it and say that it's the previous setup. By writing Vn is Tn plus Pn squared, show that Vn has degree 2. Right, okay. So if we've got Vn is Tn plus Pn squared, so we've got a Vn plus 1, so that will be Tn plus 1 plus P times n plus 1 squared. So that's our left-hand side. And then the right-hand side, so that is going to be equal to then half of, so Vn plus 2 is Tn plus 2 plus P times n plus 2 squared. And then we've got a Vn, so plus Tn plus Pn squared. And then we've got that minus P. Right, I'm going to need a long line for this, so let's go all the way down the bottom and expand things out. I'm not too sure what I'm trying to do with this, but there's a lot of P's and N's, which I feel as though I want to tidy up and see what drops out the bottom of all of this. So I've got Tn plus 1 plus Pn squared plus 2Pn, so just expanding out, plus P. So that's the left-hand side. Then I've got a half of Tn plus 2. Then I'm going to have a Pn squared. Then I'm going to have a 4Pn. and then a 4p. Okay, then I've got the Tn, then I've got the Pn squared, and then I've got the minus p at the end. So what have I got for Pn squared? So I've got one of them on the left, and I've got half of two of them on the right. So they're all cancelling out, so that's good. They will go away. 2Pn and 2Pn. Oh wow, okay, this is really simplified. Then I've got a p on the left, and I've got a 2p minus a p on the right, so that's all disappearing as well. So I've got barely anything left here. So I've got Tn plus 1 is equal to a half of Tn plus 2 plus Tn. Okay, and that's what we've just been dealing with in the previous part of the question. So that's got to be significant in some way. So what do we have on that? So that's saying, so any sequence this, which satisfies that. So this has got degree of at most 1. That's what we found out. So maximum degree, we found out in the previous part of the question, that has got maximum degree 1. And what am I actually even trying to do here? I've forgotten what the question is in part 2. So I've written out that, okay, show that sequence Vn has got degree 2. So I've got that Vn is Tn plus Pn squared. Okay, so this bit has got degree 1 or 0 if, could it have 0? Can't remember now, or was it just, well, it says at most 1. How did it end up being 0? Let's go back, look at the previous bit. So, oh, if d is 0, as in we're just getting the same number every time, then we get degree 0. Yeah, okay, right, so that's fine. So it does have degree 1 or 0. It's just, yeah, that at most 1 there. So maybe I should have gone back and put that in here. Polynomial of n, in n of degree 1. So, or degree 0. Probably shouldn't call this d, should I? Because we've got d here, is that degree. If, well, d equals 0. Okay, right, but degree 1, maybe I'll call this something else instead. Oh, they've used up so many letters already. So let's call that G and make that a G and that a G. It sort of looks a bit like a D. Right, okay, so that's clarified a little bit in the previous part of the question. And then, so that's got degree 1 or 0, and then that has got degree 2. So we can see that therefore Vn has degree 2 because, or could it have degree 1 or 0? It says it specifically, oh yeah, p is non-zero, as p is not equal to 0. Right, okay. Right, now we've got, given that v1 equals v2 equals 0, find vn in terms of n and p. Right, so v1 is t1 plus p, and that's equal to 0. v2, that's just putting it into here is what I'm looking at, is equal to t2 plus 4p, and that is equal to 0. So what does that tell me? That tells me that t1 is minus p. It tells me that t2 is minus 4p. I also know that t is an arithmetic sequence where tn is an arithmetic sequence, because this is what we just found out down here, isn't it? It's this thing. So an arithmetic sequence. So we've got first term is minus p, difference is minus 3p. So I now need to get Vn, so I've already got the Pn squared, so I've got Vn is equal to Pn squared, and then we've got the Tn bit. So the Tn is minus p, and then I've got this thing here, so minus 3p times n minus 1. That is, yeah, so that is it, isn't it? I think, all in all. Yeah, I don't think I've got anything else really to say on that. we've got, in the end, I mean, I suppose I can just simplify because some of those, I've got too many p's here, haven't I? I have pn squared minus 3pn and then plus 2p. So that just gets it into a nicer format, and that's our degree 2. Right, okay, so this is all coming together. Right, so last part of the question. New sheet. Sequence wn satisfies that. Right, so we've got the same bit at the start again, but now we've got a minus an minus b, where a and b are constants. A is not equal to 0, so we can't get rid of the n that's there. We have to show that that's got degree 3. Right, so we're doing the same thing again, and we've got to show it's degree 3. Kind of makes me think that we're going to have a substitution with an n cubed here, I suppose. I mean, that seems likely, doesn't it? I mean, I don't really know what else I'd go for. So if we were to say that wn was tn plus, what constant am I going to have in front of it? Because they've picked out p here to go with that, but now we've got an a and a b, so I don't really know what I'd put there as the constant. So let's just come back to it. Maybe I'll just say c n cubed. I don't really know what to say with that. So where, okay, I'll just say where c is not equal to 0 and constant. Okay, and then I suppose I'll just whap it all in again and see what happens on all of this. So I'm going to have, what have I got? wn plus 1 then. I have to go back down the bottom again. So that is going to be t n plus 1 plus c n plus 1 cubed. Okay, so that's the easy bit. And then we've got a half wn plus 2 t n plus 2 plus c n plus 2 cubed. This is going to be quite unpleasant, I think, doing this. And then we've got a tn plus cn cubed minus an minus b. Right, this is going to be an enormous amount of writing out on all of this, isn't it? Although looking at these cubes, I'm just seeing if anything, because we had so many things that cancelled on the last one. Can I save a bit of space here by not expanding out everything? So I'm going to get a cn cubed on the left hand side, and I've got 2 cn cubes that are then halved on the right hand side, so I can ignore those. They're all just going to get cancelled out. So what about my cn squareds? I'm going to have 3 of them on the left, and then in here I'm going to have 6 and then halve them, so they're going to cancel as well. So I can say, right, the cn cube and cn squareds cancel. What about the cn's? Well, there's nothing on the, well, there's not going to be enough, is there? Because I'm going to get 3 on the left here for the, not the cn squareds, the cn's. So I'm going to get 3 on the left, and then I'm going to get 4, 12, 6 on the right. So that's not going to cancel out. So yeah, I'm going to have to deal with that. So I'm going to have 3 of them kicking around at the end. So 3cn on that, and then I'm going to have a c on this side. How many c's have I got on the other side? I've got 8 of them, 4 of them. So another 3 there. So plus 3c. Okay. Minus an minus b. And then I've got this bit as well. I've still got the half tn plus 2 plus tn bit as well in there. So that's tn plus 1 is all of that. Okay. So what does that mean? Well, let's group these n's together, turn it into something of interest at the end. So I've got a half tn plus 2 plus tn. So I've still got that thing, which we know has got this degree of 1 or 0. And then I've got a plus n 3c minus a. So that's that bit. And then at the end, I've got a 3c minus b on there. So what does that mean? I mean, it looks very similar to what we had before. But because what exactly did we have before? Let's go back and have a closer look at what did I get here. You know, I had these things, those things. Yeah, I mean, it does look very similar. Actually, it's this thing that I should be looking at, isn't it? Here, this is the thing that it looks very similar to, because we've got, yeah, I mean, it's pretty much identical to that thing. And we've got the same bit here. So this is working out. So this has made this substitution for Wn. It's giving me information about this bit, which I need to say has got a degree, which is, well, providing it's 3 or less, we're all right. Now we know for this part of the t's, this is looking, well, and if we've got this bit at the end, because we can still have a constant at the end of it, if I can get rid of this bit here, then it's exactly the same as part 2. So, and that is determining what our constant is, right? Okay, yeah, so it is coming back to, right, that took me a while to spot. So don't know what the constant is that I've put into this, but this is going to help. So you can say, right, so let's let 3c equal to a. So if c is a over 3, then we've got that this solution, then this is the same as part 2 with 3c minus b being equal to minus p. So yeah, so we're saying that, well, 3c is a, so we're saying that we got b minus a equals p. Okay, right, so I've fitted all those things together. So therefore we've got that Tn is degree 2. Therefore, Wn is degree 3 because we've got an n cubed in it. Right, okay, so that has come together as well. It was a bit fiddly working out what to do with that constant, but yeah, I could kind of see it there matching up. But it took me a while to spot that step, I think, of going from. You could see, I could see it was similar, but it wasn't immediately obvious exactly in what way, because we've got this same thing with t going all the way through it. So all the equations look quite similar to each other. But yeah, we've managed to match up with this thing here. So now what I've actually got then? So I've got to do, given that W1 is W2 is 0, find Wn. So we know Wn. So what have I got for Wn? Wn is, oh good lord. Right, so we know it's a cubic in n, and I know what c is, so I've got that bit because c is a over 3. So I've got a over 3 n cubed, so that's definitely fine. Then I've got a next bit, so that Tn is the same as Vn, so I'm going to have a Pn squared in it. So that is b minus a n squared. Okay, so that's done that bit. And then I've got, so that, and then I've got this Tn bit in here. So that is going to be, I'm just going up to the next part of the question. But they've given me some numbers. Maybe this is the bit that I don't know as to what it's going to be. Yeah, don't know. I mean, we've all got A's and B's there. They've given us 2 numbers. So it does feel as though, even if I don't know, which I don't know what the coefficients are at the end. So what letters have I not used? H-I, let's go for M, and oh no, have I had M? I haven't had M. I've used so many letters for this. They really have used, I haven't had an R or an S. Let's go for R's and S's. So let's say R times N plus S. Okay, so, but at least I'm fine on those first two constants. Those first two coefficients we have actually worked out, so that's okay. So W1 then is going to be A over 3 plus B minus A plus R plus S, and that is equal to 0. Then I've got that W2 is 8A over 3 plus 4B minus A plus 2R plus S, and that is equal to 0. Right, so I can fiddle around with these, and yeah, I suppose I just have to solve these and get what R and S are. Right, they're kind of annoying though, aren't they, the way they've done these? I mean, I can eliminate S easily enough. So let's subtract the top one from the bottom one. So I'm going to get 7A over 3 plus 3B minus A plus R is 0. Right, okay. So, well, at least it's given me what R is, isn't it? So we've got a 3A minus 7A over 3. So that's 2/3 of A. R is 2/3 of A minus 3B. So that's dealt with R. And then what am I going to have for S then? So S is going to be equal to 2/3 of A minus B minus R. So that's 2B. So minus 2/3 of A plus 3B. So S is equal to 2B. So I just have to, I'll run out of space on the screen now, but I'm just putting those two values of R and S into here. And then we got WN. Okay, that was, yeah, weird sort of question. It felt as though I didn't really know what I was doing all the way through it, but it worked out okay. So interesting technique that they put together here, but it's sort of going through it with a bit of blind faith that if you just do the algebra as they're suggesting, then you're going to end up where you want to be. So yeah, slightly uncomfortable question, which, as I say, has worked out fine, but I don't tend to go for the sequences questions on STEP if I'm given the choice. I'd imagine a lot of people would skip this one and go for ones that are a little bit more straightforward, you know, your calculus questions or your graph sketching or mechanics if you're particularly that way inclined or whatever. But yeah, I mean, it was fine. It was quite an interesting way of figuring these things out, but it's not a technique that is easily thought of. Like, you wouldn't just come up with, oh, this is how I'm going to solve it in order to work out what the degree is of these sequences, which always makes it a bit just groping around in the dark until the answer drops out. But yeah, it was fine.